for the folks who just joined, today is a work day. I've been taking a little too long with our lessons and not having enough time to do the homework as a group. The format of this Zoom class with me is that we go over how to do the types of math, and then we have time to do it together as a group. And then if you have any questions, we get on the spot tutoring, help, and feedback right away. So I've just noticed that a lot of people, and if we're still not making progress today, I'm going to be calling home to your folks and or talking to your teachers and say, hey, student XY here hasn't done all 3 of their tests yet. They're not even started. And they're not asking for help, which means we're not making progress. So work on it now. Let's try to finish all 3 right now, today, with me. So we should be logged in and doing expressions or linear equations or solving linear equations, mastery tests. And if you need help, just tell me. We're going to do it together.
Josiah, I need help on the first problem.
Okay. Tira, would you mind sharing your screen so I can see it real quick?
Yeah.
Okay. Go for it.
Let me see. Do I go to desktop or application?
Let's do desktop. I think that'd be best.
Okay.
Less bugs that way. Okay. Yes. I remember this. Keep it up for a second. I think we did one like this similar either yesterday or Monday. Okay, you can stop sharing. And I'm going to... Okay, so come back to the screen with me, Tira. Here we go. So here's the question that you were given. It's a long equation, and it has fractions in it. So we've got multiple balls in the air, so to speak, to juggle here. Now, there's a couple of key principles that we're going to use over and over and over, and they apply to this problem too. One of them is combine like terms, and the other one I noticed that we'll need is when adding fractions, we have to have the same denominator. I think those are the only real big rules we'll need to remember for this problem. So let's start by combining like terms. We want to combine all the p numbers and the non-p numbers. So let's start with the non-p numbers. I think they'll be easy and fast. On the left side of the equal sign, Tira, I only see the +7, right? There's no more numbers like that don't have a p on the left side. So there's nothing really to add to that 7 on the left side. But on the right side of the equals, we've got +5 +4. So we can, in theory, combine the 7 and the 5 and the 4. So because they're on opposite sides of the equal sign, we're going to -7 from both sides. The reason is, remember, we can't pick up and drag the 7 across the equal sign. We have to use one of our properties of equality. So what we're doing here is the subtraction property of equality to kind of get rid of 7 on the left. Remember, because 7 minus 7 obviously cancels out to 0. And then we can now combine the 7, even though it's negative now, with our 5 and 4. So kind of regrouping to see where we're at now. We haven't touched the 1/3 p or the 1/2 p or the 7/6 p. But now we can add together our 5, our 4, and the -7. So let's do the 5 plus 4 minus 7 in our calculators. And double check me, but when I did it, I got +2. That's 5, 4, and -7. Any questions so far, Tira? Please.
No.
Okay. Okay, now let's deal with the fractions. They're probably the tougher nut to crack. So remember the rule is we can only add and subtract fractions when they have the same denominator. So we're going to make the fractions have the same denominator in this case. I'm going to change my color real quick, just in case that's helpful. I want to multiply 1/3 p by 2 over 2. And I'm going to multiply 1/2 p by 3 over 3. There's a
So,
yes, go, please.
um, I was gonna ask you like why are we multiplying it 2/2 to 1/3 and then 3/3 to one
Sure. Yeah.
over?
Thank you for asking. So the reason is we have to have. I'm going to come back to the screen. We have to have matching denominators when we add fractions or subtract. Okay. Because here's what's happening. Side example. Let's say we wanted to just add a fourth plus a third. Think of fractions as units. This is 1/4 and 1/3. You with me so far?
Yes.
Side example. I'm sorry to kind of move to the side. We'll come right back to the actual problem, but it might be easier with some different numbers. So when I see this problem, I want to visualize, well, what is a fourth, right? Think of like two different, forgive me, I hope this is okay. I think of like pizzas, and because they're kind of easy to cut up into fractions. So here's 1/4, and then here's 1/3, right? It's not the same size section. It's cutting the pizza into 3 even sections. So hopefully that's even. So we see this way visually that a third is bigger than a fourth is. And this is why we have to have the same denominator when we're adding fractions so that we can basically count them up in the same like chunks. Right now, my fourth is, this amount and my 1/3 is the other shaded amount, but this is a little bigger looking than a fourth. It's kind of like saying add miles. This is another aside. Miles um, plus feet. Well, okay, they're both distance, but they're not measuring the same amount of distance. So we have to convert our miles to feet or our feet to miles in order to add these. And it's the same idea with fractions. We have to have the same denominator. So to make them the same denominator, I'll keep using the fourth and the third. We want to somehow, some legal way, make them have the same denominator. Basically, when we do that, we're turning them into the same unit, so that way we're adding up the same like chunks back to our pizzas here. We'll have them in the same size chunk. So the easy way for us to do that, and it's useful that it works out this way, is we can multiply the number one to anything, right? Because 1 times a fourth is still just a fourth. So that's okay. Now, but I also didn't really get anything done there, right? I didn't do anything useful by multiplying the number 1 to 1/4. But remember, Tira, anything divided by itself, for instance, 3/3, 3/3 divides to become 1, right? Anything divided by itself becomes the number 1. So if I choose to look at the other number's denominator, which is 3 in this case, and multiply my 1/4 by 3/3, now this becomes 3/12. We're multiplying across the top and across the bottom. And if I do the same thing to my 1/3, look at the other fraction's denominator, which is 4, and do 4/4. So notice, look at the bottoms of each of those multiplications, Tira. 3 times 4, 3 times 4. So what we've done is we've manipulated our original problem. We've changed what the two fractions look like,
Oh, so you made them the same.
and we made them the same. 3/4, or I'm sorry, 3/12, 4/12. And we've made them the same. So if I could cut these into pizzas, um, it's real hard to do 12ths. So let me see if I can handle this. I've already messed it up. The point is we're measuring the same slices this time. So this would be 3 slices, and this is 4, and they're the same like size slices, assuming that I did a proper job of cutting them up, but I didn't. The point is we've made them the same. They're the same units, and now we can count up 3/12 plus 4/12 is 7/12. And that's why we're doing that. So whenever we have to add fractions, this is the fastest, easiest way to get them to add or subtract, is to multiply them each by a number over number, a number over number. And where are we getting those numbers from? It's the opposite denominator. So we're on purpose doing 3 times 4, 3 times 4. And back here, we're on purpose making it 2 times 3, 2 times 3 for your actual problem in the test.
And it
So
makes sense because, like with the 1/3 and, 2 times 2, like that matches with 7/6 p.
And yes, very good. You noticed that. Good. I think they were giving us kind of a break in this problem by making that a sixth for the 7/6, because these were going to become sixth when we did it this way. So they're giving us kind of a break, which is nice because I was expecting it to be more work. But now the good news is we can combine these like terms. The p numbers are all fractions with sixth denominators. So 2/6p plus 3/6p on the left, that's 5/6p. And now I've got to move my 7/6 over. So we're going to do the opposite to kind of move it across the equal sign, which is subtract 7/6p from both sides. We're doing the subtraction property. Okay, so it's kind of hard to see when I wrote it up like below and above each other. But on the right side, 7/6p minus 7/6, well, those cancel. On the left, we're asking 5 minus 7. Okay, this is a little tricky, but it'll be a negative. 5 minus 7 is negative 2. So I'm going to continue here. So negative 2/6p equals 2. Actually, one moment. I'm going to do this. I'm going to continue above. So we've got negative 2/6p equals 2. Okay, now a couple things we could do. We could reduce this fraction, 2/6. So I notice they're both even, so I divide the top and bottom by anything that matches. 2 and 2 would work, divided by 2, divided by 2. So that's 1/3 p equals 2. Same thing. And now we want to get that p all alone. So we're going to multiply the reciprocal, because it's a fraction, Tira. Instead of dividing both sides by negative 1/3, which also would work, but it's just harder to deal with, more steps. We're going to multiply both sides by the reciprocal of negative 1/3, which is negative 3/1. And the reason I'm doing this is to get that 3/3 cancel. And negative times a negative cancels. So we have p equals negative 6.
Okay, I think I got it now.
It's a lot of steps, but the two major.
I
Go ahead. Sorry.
Oh, sorry. I actually wrote it down on my notes too, so that should be helpful for my next problems.
Very good, Tara. Okay. Any other questions right now?
Nope, I'm good.
Okay. Anyone else have a question you see that you want help with, ideas on, got stuck on?
I need
Con-
help.
yes, go ahead.
Do you want me to share my screen?
Yeah, that'd probably be best. Go ahead and share your screen. Okay, Anaya, thank you. What is the value of the expression when x is equal to -6 and y is equal to -1/2? Let me just write this down, and then I'm going to take over sharing again.
Okay.
So what they're asking us to do here, Naya, is to basically simplify the expression, but we have to first plug in numbers for x and y. And they're giving us those numbers in the line above. They're saying x is going to be -6, y is going to be -1/2. And then we have to plug those in. And then we have to like go through our order of operations to simplify it down to hopefully just one number. And I'm going to take over. Thank you for sharing. Okay, so here's the expression that they gave you: 4 times x to the second power plus 3, and that's all in a parentheses, minus 2 times y. And then kind of to the side, they tell you x is equal to -6, y is equal to -1/2. So our job is to simplify all this down to a whole number answer, or maybe it's a fraction. Hopefully it's a whole number. But before we can do that, we've got to plug in our x and our y. So a lot going on here. Let's start by plugging in. And remember, plug in means substitute. So I'm going to switch out -6 with x. And I'm going to switch out -1/2 with y. Now, I used extra parentheses because the numbers they made me plug in are negative. And I think it's a good idea to always use parentheses, um, especially when it comes to like multiplication, like my -2y. Well, that means -2 times y. So I'm going to like group together my y number with parentheses for the time being because it is a negative or minus half. And same deal with my -6 for x. It just kind of helps bundle it together so we don't lose that negative sign. Okay, now we want to use our order of operations. So recall from last week and earlier in life, I know you've used it before. It's PEMDAS. That's our shortcut to remember it. And that means parentheses, exponents if there are any, multiplication, division, addition, and subtraction. Top down. So basically, do any parentheses that we have. Um, and then if there's stuff inside the parentheses, then we kind of like restart the PEMDAS and say, okay, well, then I want to do my exponents first, then any adding, then any multiplying or dividing, then adding, subtracting. So let's try to do our parentheses first. So inside this bigger parentheses, I've got an exponent and then I've got adding. So let's do the exponent first. So -6 times -6. So side work, remember negative times a negative is positive. And then 6 times 6, we have to do that, is 36. So because it was a -6 we plugged in, this squares or second powers to become positive 36 plus 3. So we can add those now. That's 39. Okay, now what do we have? 4 times 39 minus 2 times -1/2. So we've got some multiplications and then a subtraction. So let's do our multiplications. 4 times 39 What's that come out to? Did you get it already?
Yeah, 156.
Thank you, Anaya. So that's 156 minus, okay. Any questions on this part? 2 times 1 half. It's all good. It's all good. I'm gonna show it real quick. So we're doing 2 times negative 1 over 2. We've done some fractions today and as a group last week and this week. But just recall a whole number like 2 multiplied to a fraction. You can put a 1 underneath the whole number, and then we just multiply across the top and across the bottom. So this is negative 2 over 2, which of course turns into negative 1 because anything divided by itself is 1. So this all turned into minus negative 1. And now we're almost done. I want to subtract minus 1, but remember, minus a negative. This is another one of our early foundational math rules. Minus a negative turns into a positive. So this is 156 plus 1. It's a double negative. Remember, it happens with language as well. I was talking to I was talking to you yesterday about it. I think not happy means I am happy. I'm not happy means I am happy. So it cancels out in language as well as in math, and we get 1, and then it's looks like it's 157. I hope that is helpful. Any other questions right now? Please.
No, thank you.
Yeah. Anyone else?
Hi, I actually am having problems on question 3.
Okay. Tira, show me your question.
Okay.
Okay. So this is kind of like the one we did earlier, except honestly, at least there's no fractions in it. So I think this is a tad easier, or at least a tad cleaner, right, to start with. Tira, can we start by combining like terms on the left that you see, and then any like terms on the right that you see?
Um, 4x and 8x.
Okay, so 4x and 8x are like terms. Very good. And there's the 2x too, right? So I want to combine all three of those. Um, so since I've got 4x on one side, and then on the other side we have 2x and negative 8x,
Mm-hmm.
I want to move that 4x over to be with the other x numbers. So it's positive 4, right? It basically is saying like plus 4x minus 3 plus 5. Since that 4 is positive, we're going to minus 4x from both sides. You know what? I'm going to write it down and I'll throw it up on my screen. 4x minus 3 plus 5.
Did you want me to stop sharing mine?
Not yet.
Okay.
There we go. Okay, now you can. And screen sharing party. All right, so start by moving that 4 to be with the other x numbers. Here's our original. So I'm going to imagine subtracting away 4 x's from each side like this. Remember, when I say side, I'm referring to like the left and the right of the equal sign, two sides. So on the left, 4 x's minus 4 x's, they go away. That was by design. And while we're at it, Tira, let's combine the whole numbers that we see on the left side. So negative 3 plus 5, we could reverse the order and make that 5 minus 3. So what does that come to?
That would be 2.
Absolutely. Thank you. And now I guess I'll carry everything down and we'll start combining stuff. So we have our 2x plus 7 minus 8x minus 4x. Okay, so we want to try our best to focus in on the like terms, even though they're all not next to each other. So right here, 2x and negative 8 and negative 4. So in my mind, I'm separating those out and just saying 2 minus 8 minus 4. Tricky because of all the negatives. So, and it's 3 of them, not just 2 numbers. So we'll do it in 2 steps, okay? So 2 minus 8. The difference between 2 and 8 is 6. And because the 8 is bigger, right? 8 is a bigger value than 2 is, then there's leftover of 8 sign. There's leftover negative. So our answer is negative 6. So negative 6 minus 4. Okay, now this time they're not working against each other. They're both negative. So it's like I'm down 6, and then I go down further 4 for a total of 10 down. So what I'm doing here is combining together the coefficients for my x numbers. So we're left with negative 10x. So what do we have? We've got 2 equals negative 10x plus 7. Tira, any questions on that, please?
Yeah. So for 2 and 8, why did we prefer 2 and 8 and not 2 and 4?
We could totally do 2 and 4 first.
Oh, okay.
I only
Okay.
did it that way just because the way I wrote it was they were next to each other.
Okay, cool.
But the truth is, we can add them in any order you want. So if you had done it part of me, Tira, was thinking, let's add together the negative 8 and negative 4 first, just because they're both negative.
Right.
And then that would be, let me try it here in purple. That would have been, I'll do it with a little line between them. So starting again real quick, our 8 and 4, they're both negative. So that would be 2 minus 12. Remember, the 8 and 4 are kind of stacking up together in the negative direction because they're both negative. Now, 2 minus 12. The space between 2 and 12 is 10. And whoever's bigger out of the 2 or the 12, their sign is left over. 12's bigger, so there's negative left over, so negative 10.
So we would have got the same.
We should get the same, yeah. And we can mix and match. You can add them however you prefer. Yeah.
Oh, okay.
Meaning the order, right? We can do them in the order you prefer. Okay, so now we've got more like terms. We've got the 2 and the 7, but they're on the opposite sides. So remember, we want to move our x number, like the 10x, on one side, and then the non-x numbers on the other side. So since negative 10x is on the side it's on, I'm going to move the 7 away from it. And remember, we have to do the opposites to get stuff across the equal sign. So I'm subtracting 7 both sides. And here we go again with more subtraction. It's 2 minus 7. The space between 2 and 7 is 5. 7's bigger, so there's negative left over. Okay, and now finally we're down to one step left. And this is where I started things on, now I don't remember which day it was, but when we started solving equations, we look at the variable. What's happening to the variable is it's negative 10 is being multiplied to x. So I want to divide negative 10 from both sides. X is equal to 5/10, but always ask yourself, can I reduce this fraction? And also, it's not negative over negative anymore because, again, the double negative rule kind of kicks in and it becomes positive. So anytime we have negative times negative or negative divided by negative, it becomes positive. So we have 5/10. Reduce that down, and that is 1/2.
So for the 5/10, we divided 5 by both sides.
Very good. Yes, I divided 5 on top and 5 in the denominator. We can do that with like any number that works for you, any number that works for those numbers. And in this case, I notice, okay, 5 can go into 5, obviously, and then 5 can go into 10. And so it worked out nicely. We've got about 16, 17 minutes, I think, on the clock I'm looking at. Any other questions right now, please?
Um, can you reopen my test?
Oh, yeah, definitely. Let me stop sharing. I'll check and see if anyone else needs a unlock or something.
जरूर कर रहे थे सही सीधे
All right, I'll check and see if anyone needs an unlock or something. And if there's anyone else with the questions, I'd like to help you with that before I lose you today. We've got about 15, 14 minutes left now. Good work, though. I'm real happy to see all these names in here. You guys knocking stuff out. Very good. Nice. Joseph, I see you did one already. Maria Celeste, good job. Lauren's doing one, or finished one, I should say. Anthony, thank you, Anthony. Good job. Levi, high five, Levi. Boom. Knocking out expressions. So I hope it was understood that if you finish one of these, don't just stop there for the day and bounce. Do the next one. My goal for today is to try to get through all 3 of those first 3 mastery tests with you. And people who didn't pass it, don't be hard on yourself. What I'd like you to do is try it again and tell me and say, hey, Josiah, I want to do problem 1 with you, or problem 2, or whatever it is. Everything should be reset. So if anyone needs an unlock, should be good to go. Just reload your page.
Hi, Josiah.
Hey, is that Levi?
Yeah,
Hey,
I just sent you a message through the Remind,
Okay.
letting you know that I got kicked out because I was having internet connection issues, and then my computer shut down.
Oh,
So I had to
dude.
turn it off and then log back in.
like everything at once.
Yeah.
All right, sorry about all the drama. I didn't realize you had gotten like dropped from the call, and I was just giving props to everyone I saw who did finish at least one test today, and I saw you did. So nice job from what you did get done earlier.
Thank you.
Thank you. I'm glad you're back. We've got about 12 minutes left. So if what everyone should be doing is on to your next mastery test. If you finished one today, high five. Move on to your next one. If you're stuck on a question, you ask me for help, we do it together. Okay. Sorry, Anthony, I just saw this message. The chat is okay, but honestly, folks, for me, it's a little. I honestly prefer if you could just turn on that mic and tell me because I won't miss it that way. It's just more in my face. Let me make sure I reset that, Anthony, right now. Okay. I think you're good.
Josiah,
Tira.
when you get a chance, I was going to ask you if you can help me on question 4.
Absolutely. Um, Go ahead and share your screen, and I need to really quick write down everyone's names who I didn't add on yet for today's attendance, and I'm going to do that. Share your screen and show me your question.
Okay.
Let's see.
So I already attempted to do it, but I'm just not sure if I'm right.
Oh, nice job. Let's see. So okay, the first option you said subtraction property. Yes. Um, yes. The subtraction is minus 17 over 3. We see the same thing on left and right. They basically subtracted out 17 thirds from left to right. Good. Then simplification. Why is that? Well, what they did was 17 thirds minus 17 thirds. And on the right, they added the 5 and the negative 17 thirds. Good. So for the one missing in the middle, let's look at the line above and then the one in the middle, the one that we haven't answered yet.
Okay.
Can we see what is different? What's the same and what's different? That'll help us see what's different if we can locate what is the same from simplification to the missing one.
Are we looking at the which ones are we looking at again?
Sorry, Tara. I know. I wish they would have numbered them. That would have helped. So, okay, looking at all the lines, it starts with given, right? And then the one you answered, subtraction. And then the third one, I guess, is simplification. And then so line 4 is the one that we haven't answered yet. So let's compare line 3 and line 4.
Um, let's see. I noticed that they both do have 3/4 and 1/2 and 2/3.
Good. So what's good? Very good. So what's the only other item that's there that isn't in line 3?
The 1/2.
Uh-huh.
Well, the
Uh-huh. Good. And notice how it's on the left and the right. It's minus 1/2 x. And then on the other side, minus 1/2 x. You see that?
yes.
Because it's on both sides, what they're doing is they're subtracting the same thing from both sides.
So that would have been subtraction property of equality.
Yep, it is. And it's not like the first time you did it, it's wrong. I think they're just using it twice here.
Okay. Cool.
Yeah. And let me just double check. I think the rest are all good. Yep, you got the other ones right.
Thank you.
Yes, thank you. Okay, so I noticed that some folks left throughout the meeting, so I hope they made it back if they were just losing internet. So I don't count them as absent today. So we've got Bearcat here. We've got Robo. We've got Jaden, Davey. Where are you? There we are, Davey. Tira's here. Levi's here. Philmon and Anthony Ravelis. Good. We've got Moose. We've got Victor. We've got Beniam and Anthony. We've got Joseph and Anaya. And Lauren was here. She left early. I'm going to mark her down
Me
as.
too. So I take it the test.
Wait, who's that?
Yeah, I take it the test. Me too. From here.
You did your test today, Robo?
Yeah, I do it now.
Give me a high five, man. High five.
Yeah,
High five. Real high five.
yeah.
Boom. Thank you.
Boom.
So, yeah,
Yeah.
if I'm happy that you did the first one or you're doing it now. Do you have any questions, Robo, that I can help you with? Can I help you with any of your problems on the test or questions on the test? No. Okay.
Oh,
It-
if I have a question, I tell you.
Good man. Thank you. Let's see. Savannah was missing today, but she did have her homework done. So,
So just I finished solving linear equations.
yeah.
After that, do I just do the next mastery test for today?
You know what? Stop there. You've done the first three, correct?
Yes.
Okay. So that's where I want everyone to stop at. There's some information I want everyone to have before you do the fourth one. So tomorrow we'll do a short, hopefully short lesson. I'm working on it, folks. I'm gonna try to keep it short and sweet, so that way we have time to do our test together afterwards. So, Tira, you're good for the day. Thank you for your hard work.
You're welcome. Bye.
Bye. And you know what, everyone? It is almost 12. So I'm going to go ahead and say you're all excused for now, for today. Thank you for your hard work. If you're still missing tests, your job today is to do more of your math tests. Okay, up to the first three. Tomorrow we're going to do the fourth one together.
Okay, teacher. Thank you so much.
Thanks, Robo. Have a good day.
Yeah. Have a good day.
Levi, see you tomorrow. Barracat, are you there, bud? Looks like you're fixing something on the wall or something else. I don't know.
I have one question, teacher.
Yes, Philman.
Can I share the test? That's hard.
Of course. Yeah, please do. Share a screen. Do you know how to do that?
No, I don't know how.
No problem. So in the Zoom call here, not on Admentum, at the bottom of the Zoom call, you should. Oh, there you go.
Right there.
You started it, but it closed. Try. Oh no.
Yeah, that's close, but I just need the.
Actually,
I
no.
don't just.
It says it's good. Okay, good. Let me look at your work. Is that a divide? Negative 2x divided by 3?
Yes.
Okay. So I think I see the issue. Just one moment. One moment. Let me write it down. 5 minus 6x. And then you said negative b minus 6. Okay. I'm going to take over again, Philman. Hang on. So come back and look at my screen with me.
Okay.
Okay, so negative 2x divided by 3 minus 5 minus 6x. Okay, and then you found off to the side here, you had negative b minus 6. Maybe the issue is just that you used a b and not an x? Let's find out. I'm going to just put that to the side there. We'll look at that in a sec. So there's a couple things here to do, man. We need to do our order of operations, right? So do our parentheses if we can. Here, I'll write it down. Parentheses. And then exponents, there's none here. And then multiply, and then divide. And then add, and then subtract. Okay, so we can't do the parentheses because this is an x number and this is a non-x number. So we have to hold off on those for now. Um, I guess technically we can do this division. It's going to make a fraction, unfortunately, though. So right here, Philman, right here, we have negative 2x divided by 3. So we should do that division before we add or subtract anything. So that'll look like this, negative 2x divided by 3. Then the rest of it. Excuse me. Because this is a minus parentheses, remember distribution, if we had a number being multiplied to the parentheses? Well, we want to essentially distribute, Philman, the negative sign, the minus sign right here, to everything inside the parentheses. So our 5 becomes negative. Our negative 6x becomes positive. What we're doing is we're like kind of handing it out to everything inside the parentheses. Okay, now we've got negative 2/3 x and 6x. Those are our like terms this time. The problem, though, Philman, is one's a fraction and one's not. So we need to, I talked about this with some other students this morning. We need to make our 6x have a 1/3 denominator. Okay, so here's how I'm going to do that. 6x, I want it to be a fraction with a 3 in the bottom, with the 3 in the denominator. So I'm going to multiply my 6x by 3/3. And it becomes 18/3. X. Don't lose the X. So back to the problem. Okay, now like terms, the X numbers and the fractions, they're ready to go. So this is like saying 18/3 X minus 2/3 X. Okay, because this one's negative. So the 2/3 is negative. So it's kind of like saying, I'm going to put them in a different order just to show the work. 18 minus 2 is 16. So we have 16/3 x minus 5. And I think that's it. It's a very complicated problem, but it does good because we have to do fractions and we had to do distribution and we had division. So it was a pretty good mix. I think this is our correct answer. Unless I made a mistake.
10/3.
Yeah, for the one you showed me.
Oh,
There's a lot going on here. We did this division in the very beginning, right here at the top. This part here, negative 2x divided by 3. We should have started with that. Because we can't do the parentheses because it's like 5 and 6x, right? Those can't add, they're not like terms. So that means we could start then with this division. But it creates this terrible fraction, negative 2/3 x, negative 2/3 x. And then that led us to having to add it to the 6x later. And that ultimately led to having 16/3 x minus 5. Any questions, Philman, on this at all? Please.
that's clear. Yeah. Thank you.
Is that okay?
Yes, that's okay.
Okay.
All right. Thank you.
Of course. Have a great day, and I'll see you tomorrow, okay?
I see. Thank you.
Bye. All right, guys. Any other questions right now? Please. Anthony, how are you doing? Did you just watch this like class and us we'll do some work today, or did you managed to get my video from YouTube and watch some of those.
What?
Anthony, how did it go for you? Were you able to find my videos on YouTube? I sent you the link, I think, yesterday.
No, I can't find the videos.
You couldn't find the videos. Okay. Sorry about that, bud. Well, I hope it wasn't a total loss for you today. Let me really quick see if I can show you. You got my email yesterday, right? With the link to come to class. You must have gotten my email. Let me double check that I sent it to you.
No, that was from a different device.
Yeah, I mean, I sent it to, looks like your mom's email, I think, and then to Dave, and then also to your school one. And then in that email, it's like my the class info, like just how the link to get here, and then at the bottom, I've got this YouTube channel link. Anthony, should I send it to a different email besides like your school email? Do you have a private one you'd like me to send it to? Let's see. Davey, how's it going, Davey? Did you get any of your mastery tests done today? Davey, are you there?
I don't know about him, but I'm here. I just finished my other two tests. The reason I haven't been talking because I'm finishing this test up right now.
No worries. I was going to check in with you next, Jaden. How's it going for you? Any questions?
I am stuck on 3.
Can you show me?
Oh man, I don't know how to share my screen.
No problem. Just come back to the Zoom call, and at the bottom of the Zoom call, there should be some options for you. And one of them is share screen, and mine is green. I think yours should be too.
Okay.
Click on that, and then if it gives you options after that, just click on desktop or like whole screen. That's easiest.
Okay, I'm getting this problem that I have with Mr. Levin. I can't share it. I go through everything, but then the share be.
No. You can, hang on. So you click on share screen, and then you should get a pop-up, right?
Yeah.
Okay, then click on like the image that you see in the middle of that pop-up, like the little picture of your computer screen.
Okay. Oh my God,
Sorry about that. I know you're not the only person who went through that same thing. A lot of people I've met in the last year, same problem. So, but now you know. Okay, show me this problem, this question.
Here, it's this one right here.
This one is a total pain. Okay, let me write it down and then we'll do it together.
All right. Yeah, that sounds good.
1/7 x plus 3/8 and then plus 2/9 x minus 1/8. Okay, thanks for sharing. I'm going to take over just so I can draw again.
Okay.
All right, where am I? Okay. So here's what they gave you. Okay, so you know what? Today was a good day for practice with fractions. A lot of people had fraction questions. This one is no exception. So, Jaden, we want to have the same denominators when we're adding our numbers, basically. So, the good news I'm seeing here is the like terms are like the x numbers and the non-x numbers. So, we are going to have to add together these two guys, 1/7 x and 2/9 x. Okay, that's not the good news. That's the neutral news because we have to make those have the same denominator.
Yeah.
But the 3/8 and the -1/8, those are good to go right now. We can combine those right now. Now, a couple of things to mention. These are in different parentheses, but the parentheses are just grouping them together. So when this problem starts, I look at it as like the first parentheses, kind of like a packet, kind of like its own.
Oh, my bad.
It's okay.
Hold on, give me a second.
Okay.
Go ahead, Mr. Henderson.
You ready?
Yeah, I'm ready.
Okay. So the point is, we've got these two parentheses, but because there's no like negative sign outside the parentheses, it's just a positive one and another positive one, and then we're adding them both together. We are allowed to basically drop the parentheses. So we can think about it this way right now, just in case that was on your mind.
Yeah, I had a feeling that we didn't have to do the parentheses.
Now, side note, if this had been like minus, like up here in the corner, parenthesis minus another one, well, then that would change the game a little bit, and we would want to hand out that minus sign to any items inside that second parentheses, okay? But this time we don't have to deal with that. So let's go ahead and clean up the 3/8 and the -1/8 right now. That's like saying 3/8 minus 1/8. You can pull them off to the side and simplify those off to the side.
Right.
3 minus 1, just 2. So that's 2/8 left over. We can not round, we can reduce that. Divide by 2 on top, divide by 2 below.
1/4.
1/4. So I'm going to go ahead and just cross those guys out back in my problem and copy down what we have and throw in my plus 1/4. That's the leftover, the simplification of those two above that we crossed out. Okay, now, sir, 1/7 x, 2/9 x. Any thoughts, first impressions on how we can make those two have the same denominator, please?
Round it up to, or multiply it till the two numbers got the same match, right?
Yes. So let's do this very good. One part at a time. So what do you think I can multiply my 1/7 by? Any ideas?
I'm pretty sure both numbers can get what?
Okay, it's okay. Thanks. I appreciate you helping me out, participating. Here's our shortcut. Okay, so we've got two fractions. Obviously, they each have different denominators. What we're going to do is pull the opposite fractions denominator, which is 9.
Right.
9/9 for the first one, and for the second one, it's going to be the opposite fractions again. So 7. So 7/7 for the other guy. And the goal here, Jaden, is I've got now 9 times 7, 9 times 7.
Right.
So whatever those two fractions are, we're just going to it's hard to describe. It's a lot. It's very wordy. We're going to look at the denominators and multiply each fraction by the other one's denominator over itself.
Right.
So it's like a weird swap, right? Like the 1/7 gets the 9 and the 2/9 gets 7/7. Okay.
Right.
Is that okay?
Mm-hmm.
Any questions?
Nope.
Okay, so now let's keep rolling. 9 times 1, 9. 9 times 7, 63.
Mm-hmm.
Don't forget about that x. 2 times 7 is 14, 63, and x. Now we can just combine those top numbers, the numerators. 9 plus 14 is 23. Double check me.
Yep, 23.
23. What a terrible fraction. 23 over 63x. 23 63rds x. Okay. So I think we're done. We've just combined the two x numbers to 23 over 63x, and it's plus 1/4. Please tell me that lines up with one of your options there.
It's the exact option I picked. I just wanted to know if I was right.
Oh, Jaden, you could tell me to get to the point if I'm talking too much. It's okay.
Oh no, I wanted to explain it all the way through. You feel me? I wanted to thoroughly get through it so I know next time that I'm right.
You did fantastically, and thanks for checking. I appreciate it.
So much.
Yeah. Anything else?
Nope.
Okay.
I finished them 2 tests. This is my last test I'm finna finish. I'm finna turn it in
Awesome.
right now.
Good man. All right.